the definition of the nonlinear system. So in physics and other, let's say, sciences, a nonlinear system, in contrast to linear system, is a system which does not satisfy the superposition principle, meaning that the output of nonlinear system is not directly proportional to the input. Once again, output of nonlinear system is not directly proportional to the input. This is the sentence which perfectly describes the difference between linearity and nonlinearity. So the best way, once again, is to compare this definition with the pictures which has been presented on the slide. And so if we take a look on the graph to the left, we see that the structural response, which is the deformation, is linearly proportional to the magnitude of the load. So deformation, like displacement, for example, sometimes this graph is provided like strain, is proportional to the magnitude of the load, like force, pressure, or stress sometimes, because this is exactly the same graph. And then if we have this linear behavior, then we know that the analysis of the structure is known as linear analysis. But if we take a look on the second picture, we see that this relationship is not linearly proportional. So for this type of cases, nonlinear analysis should be performed, and this means that the stiffness of the system will vary as function of the load. And of course there are some very important linear static features and assumptions, like for example for the linear static, once again there are very important linear static features and assumptions. Once again, this is very important. Stiffness is constant for that, as you see from the picture, and it changes changes in geometry due to displacement are assumed. Changes in geometry due to displacement are assumed to be small, and they are ignored. So very, very important two things. And now, and then on the next slide, just to introduce to you, there is a nonlinear solution procedure. So to solve this any kind of numerical nonlinear problem numerically, this nonlinear sequence is required. So at this moment we see two nonlinear solution procedures. Both of them presents incremental method to obtain accurate solution and satisfy the modeling conditions. And the basic idea of this incremental solution sounds like this. Total nonlinear response of the system can be replaced by sum of linear responses which comes from incremental loading. So we see that the stiffness of the system, if we take a look on this, stiffness of the system is updated at each load step, or we can say at each load increment. And the basic incremental procedure is not well accurate because there is a huge risk at the end of the analysis the numerical error will be accumulated. And these days the mostly used FEA method for solution is called Newton-Raphson, and this algorithm has been presented to the side to the right side. So Newton-Raphson is a little bit updated method in compared to the normal incremental method. The load is split into small increments with additional iterations performed to ensure that equilibrium or solution will be or is satisfied at every load increment. So on the next slide I would like to show you the table where some linear and nonlinear features has been compared. So if we, for example, consider the stress-strain relationship, in the linear analysis stress in the linear analysis, stress is proportional to strain up to elastic limit. And due to that, let's say scalability is available, which means if 1 Newton force will cause some amount of displacement, then 10 Newton magnitude of the force will cause 10 times more. So this is proportional, so it's very easy. Superposition, as I said, is applicable, so we can linearly combine several load cases, so we can create a lot of combinations for your roles. Reversibility is explicitly allowed, and this means that loading sequence is not important at the final state, and this loading sequence is the final state, is unaffected by the load history. So for the nonlinear analysis, this superpositioning or reversibility is a nonlinear function, so the scalability is not valid anymore. So as opposed to linear, the finite state after removal of the loads is different from the initial state, and we will experience that during the practical example, which will be a very basic example, because we will simply twist the rod, but it's very easy to implement, and it's very important to understand the basic concept of nonlinear analysis. So if we take a look more deeply in this table, we can also figure out that nonlinear analysis requires more